Hi everyone, let us see Newton's second law of motion today. We all know the third law. It's easy to remember, isn't it? When we have any force has an equal and opposite reaction, that is the third law. What is the second law? Second law says that force is equal to mass into acceleration. Here F stands for force, M is for mass and A is acceleration. Many people think mass is same as weight, but let's say I weigh 60 kilos on earth, but when I go to some other natural satellite or planet, let's say I go to moon or Mars, my weight will change, but my mass will remain the same. So mass is similar to weight, but it is not exactly same. Let us say I am going in a car at speed of 60 km per hour. That is, I go from point A to point B, which is 60 kilometers away from A. I go in 1 hour, that is 60 minutes. So my speed is 60 kilometers per hour. I think almost all kids would have traveled by car now. So you would know this, your car speed is 60 kilometers per hour. That is, I went from initial position A to final position B in 60 minutes. How do we write speed as an equation? We write it as speed is equal to distance travelled by time taken. That is, how much distance I travelled divided by how much time I took. So if I went 60 kilometers in 1 hour, my speed is 60 kilometers per hour. Now let us see what is velocity. Velocity is similar to speed. The difference is speed doesn't have direction and velocity has direction. That is, speed is a scalar and velocity is a vector. Okay, so it sounds easy, but what does it mean? Let us see with this example. Now we know that the directions are like this: north, south, east, west. One person is starting from this point. He goes 3 kilometers towards east. Then he takes a turn. He goes 3 kilometers to south. Then again he turns. He goes 3 kilometers to west. Then again he turns, goes 3 kilometers to north. What is the distance he travelled? It is 3 kilometers plus 3 kilometers plus 3 kilometers plus 3 kilometers. That is 12 kilometers he has travelled. So his distance travelled is 12 kilometers. But what is displacement? Displacement is final position minus initial position. So what is his final position? This point. What is his initial position? It is this point. So what is the difference between final position minus initial position? There is nothing. There is no difference. So displacement is 0. That is the difference between distance travelled and displacement. Now this can be a square, a rectangle, a circle. The path does not matter in displacement. So when we calculate distance travelled and divided by how much time they took, we get speed. When we know the displacement and divided by the time taken, we know the velocity. Now coming to what is velocity. Velocity is the rate of change of position. When we say rate of change of, what does it mean? Change of position, we know that we started at A, we came to B. So what is the change in position? From here to here is the change in position. That we know. That is the change of position. Rate of, whenever we say rate of, it means there is an element with respect to time. Here we are seeing this is distance travelled divided by time taken. This is displacement by time taken. So whenever we are measuring for each unit of time, for 1 unit of time, what is the change of position? When we measure with respect to time, we say rate of. Acceleration is rate of change of velocity. Now don't be scared by all these new terms. They just sound complex. They are not really. If you just try to understand, everything will become very clear. So, if this car is going at a constant speed of 60 km per hour, that means first hour also it traveled 60 km, second hour also it traveled 60 km, third hour also it traveled 60 km, then rate of change of velocity, is the velocity changing? It is always going 60 km per hour, then 60 km per hour, then 60 km per hour. So there is no change, that is, there is no acceleration. But let's say I am going in a vehicle which is going 10 km per hour in the first hour, then it is going 20 km per hour, then it is going 30 km per hour. Now what is the change in velocity? From first to second it is 10 km per hour, because it went from 10 km per hour to 20 km per hour. Then again it changed another 10 km per hour. So that is from 20 to 30. So every hour it is changing 10 km. So we see that acceleration is rate of change of position, again the change of this velocity we are seeing in acceleration. So velocity has a unit of meter per second. This unit is meter and this unit is second. So meter per second. What is acceleration? This whole thing is divided by time again. So meter per second per second. So this denominator becomes square, it becomes 2 times. Second into second. So meter per second square. Now my son is 8 years old. He keeps asking me to teach him calculus. How do you teach calculus to an 8-year-old? Very simply put, if you already know these things, please don't get bored, because I am trying to explain this to a very young audience. Calculus, you can say there are 2 main parts to it. One is differentiation, second one is integration. That is, here we are seeing with respect to a very tiny amount of time. What happens in a very small amount of time? If you want to see that, we do differentiation. Here we are integrating. That means we are trying to bring everything together for a very long amount of time. So differentiation and integration, they are kind of like addition and subtraction, multiplication and division. So this is the opposite of this and this is the opposite of this. So when you want small time, we go for this one. When you want long time, we go for this one. Now we are seeing what happens in a very small amount of time, rate of change of position. If time changes by very little, how does position change? That I am seeing in velocity. So in differentiation, I will put d by dt. Again, I am saying don't get confused or scared by all these big terms. They just look complex. You see the video once or twice or multiple times and you will get this concept very easily. Nothing to worry. So d by dt is rate of change of. Whenever we say rate of change of, we write it like this in differentiation, in calculus. So this is x of t. X here outside and inside the bracket there is t. This is seen as function of time. So the input is time and the output is, this is the function of time. So whenever I was trying to explain this to my son, nowadays kids are all very good in coding. So all kids would have tried their hand at some or the other form of coding. So my son said it is very simple. I have already learned in coding. This is input variable, this is output variable. I change something in this and I see how the whole thing changes. So that's all it is. Here we are making some change and we are seeing how this will change. And this is x of t, this is velocity. So when I say d by dt of x of t, that is dx of t by dt. This is velocity. You know what is this one? Whenever we have 2 written at the top in small, we call it square. That is this bottom number multiplied by itself. So this is 2 into 2. You know tables, so you know that 2 into 2 is 4 or 2 square is 4. Here bottom number is 3 and here it says 2 times. So 3 multiplied by 3 2 times. So that is 3 into 3 is 9. You should not confuse this with 3 into 2 6. That is not how it works. This is 3 into 3 is 9. 4 into 4 is 16. 5 into 5 is 25. We know that these are all square numbers. And this top number, we call it order, we call it power, or we call it exponent. So you might have heard the term, it exponential increase. That means it increased by lot. So here we can see, if it is 3 into 2, 6. 6 is very much smaller than 3 into 3 is 9. Here 4 into 2 is 8. That is so much smaller than 4 into 4 is 16. 5 into 2 is 10. 5 into 5 is 25. So whenever we go with this top number, as much as this top number increases, that much fast the value will keep on increasing. So this top number is called order or power or exponent. We say 2 to the power of 2, 2 square. This order is very important. We will come to this again later. Now we saw that d by dt is rate of change of. So we saw about velocity. Velocity is rate of change of position. What is acceleration? Acceleration is rate of change of velocity. V is velocity. D by dt is rate of change of. Rate of change of velocity is acceleration. How do we write this acceleration? Now V is already d by dt of x of t. So let us, instead of this V here, same thing we will write. I will write d by dt outside. Then instead of V, I will write d of x of t by dt. Now we can see d into d, here same thing is there, that I will put as d square. There is dt and dt. I will put it as square of dt square. So this by this is again 2 into x of t. So this is in independent variable or input variable is time. So it became a differential function of time, but this is a second order differential equation. So we see that this is 1, the order is 1, the same way that we saw here. The top number in this part is 1. If we don't write anything, automatically it means that it is 1. Here I have written 2 in both the cases. So it is not that you will multiply these two or add these two. It is just common number. So here we are writing 2. This is a second order differential equation. What does the second order differential equation mean? I will not go into details of how to solve for this because it may be a little too much for this age group. You will learn it very soon. When you grow a little bit older, you can learn this. But whenever we have a second order differential equation, this number 2, the order of this equation, that is 2, it is telling us we need to know two things. In this case, two things is initial position and velocity. If we know from where something is starting and with what velocity. Remember velocity, we saw that it is kind of similar to speed but with direction. So if we know from where something is starting and how fast it is going, then we can tell where it will be at a certain time. So by this way we can predict how the thing is moving. I know from where it is starting, I know how fast it is going, I can tell after so much time where it will be, I can predict. So this predictive power is very important of Newton's second law of motion. For example, some person is jumping off from the edge of space. He will not orbit the earth. He will not go round and round the earth. He will come and hit the earth. But let's say a rocket has launched a satellite, or even earth going around sun or moon going around earth. Why do these things keep orbiting? If I jump on earth, I will come back to earth. Earth is not falling into the sun. Moon is not falling into the earth. Why so? Because they have an initial velocity. When they start itself, they are having a certain speed to go round and round. Coming back to the example of somebody jumping off from the edge of space, when they jumped, they did not have any velocity. They were at rest. So initial position is there, but velocity is 0. So final position, they will come and hit the earth. But the satellite that is released in space, when it is released itself, it has a certain speed, it has a certain velocity. For that reason, it will not come and hit the earth. These calculations are done when they do the launch itself. I hope this video clears some things for you. If you have any questions, you can please leave them as comments. Thank you for watching.